Okay, it's AP Calculus, Chapter 2, Continuity. Continuity. It's first video, Continuity Part 1. In order for a function of x to be continuous at point x equals c at a certain point, it must fulfill all three of the following conditions. First, f of c should exist. Second, first condition, f of c should exist. Second condition, limit of f of x as x approaches c also should exist. What's that mean? This means we should have both limits at f of x as x approaches a minus, and it should be equal to limit of f of x as x approaches a plus, and at the same time condition 3 should be done, that limit of f of x as x approaches c, which is from the right and from the left at a minus and at a plus at should both equal to this f of c. Let's try to see what do we have here. Example 1 is the function f of x, which is equal piecewise function x plus 1 when x approaches or less than 2, and 2x minus 1 if x greater or equal to 2. Is it continuous at the point x equal to? Let's see. First, is f of 2 exists? Do we have f of 2 here? Why I'm writing in red? Let's change the color. Is f of 2 exists? Do we have when x equal to? Yes, here is the condition. So we can, we can find it. 2 times 2 minus 1, which is 4 minus 1, which is equal to 3. So the first condition, okay. Second condition, do we have limit of f of x as x tends to c? As this means x tends to 2 here, or approaches to. What's the meaning of approaches to? This means the limit of f of x as x approaches to minus is equal to what? Its limit as x approaches to minus. This means x less than 2, so it will be here in this condition. So f of x is x plus 1. So do we have it? Yes, 2 plus 1, which is equal to 3. And limit of f of x as x approaches to from the right. 2 plus is equal to the limit as x approaches 2 plus from the right means x greater than 2, and here is x greater than 2. When f of x equal to 2x minus 1, we substitute. So instead of x, its value, it will be equal to 4 minus 1, which is equal to also 3. Now the second condition exists, the first condition exists, and the third condition exists, because both, when x approaches 2 and from the right and from the left at 2 plus and at 2 minus, both equal to f of c. So is the function f of x continuous at x equal to? Yes, it is continuous. Example 2. Is f of x the same function, but there's one thing missing here. The same function as above, as you can see, but can we say about this function in example 2 continuous? No, it's not, because we have 1x less than 2, we have 1x greater than 2. Do we have at x equal to? No, so first condition is not applied, because the function f is not defined at x equal to. So in this case, is it continuous? No. This means f is not continuous. F is not continuous because it is not defined at all at x equal to. Let's go to the third example, which is okay, a little bit different. Is it, we don't have in the second part 2x minus 1, we have 2x plus 1. Is it continuous at x equal to? We have it as x equal to, we have f of 2, and what is f of 2 equals to? F of 2 equals 2 times 2 plus 1, which is 5. So first condition exists. Second condition, limit of f of x as x tends to 2 minus is equal to limit of x plus 1 as x tends to 2 minus, because less than 2, 2 minus, we have it here in the first part. So it is 2 plus 1, which is equal to 3. It exists. Limit of f of x as x tends to 2 plus equal limit of the second part, which is 2 plus greater, x greater than 2. So what do we have here? It's 2 times 2 plus 1. It's 5. Both exists. Numbers exists, right? They are not infinity. But what do we have? The third condition says they both should be equal to f of 2. And not so, f is not continuous at x equal to. Why? Because limit of f of x as x tends to 2 minus does not equal to limit of f of x as x tends to 2 plus. Example 4, is f of x, is the function f of x, this one, continuous at 2? Also, let's see. First, do we have f of 2? The first thing we do, yep, it's 2 squared, which is equal to 4. It exists. Second, what is the limit of f of x as x tends to 2 minus? It's when x less than 2. The first part, it's limit of x plus 1 again as x tends to 2 minus, which is 2 plus 1, which is 3. And limit of f of x as x tends to 2 plus is equal to the limit of 2x minus 1 as x tends to 2 plus, which is equal also to 3. They are both exists. They equal to each other. But are they equal to f of 2? They are equal to each other. Limit of f of x as x tends to 2 plus is equal to the limit of f of x as x tends to 2 minus. But they are not equal to 4. They are 3 both. So f is not continuous at x equal 2 in this case, because third condition says what? Third condition says the limit of f of x as x approaches c should be equal f of c. So as x approaches 2 in this case should be equal to f of 2, which is 4. In the second video, we will explain the types of discontinuity, and see you next video.